Good morning, everyone. This is Munir from Driftwood Studio, and welcome to the official page. I have been thinking about building a router table for quite some time, and I did actually manage to make something previously, and I would like to show it to you. We're going to the workshop. As you can see, it's a bit of a mess, but if you look here, this was my router table, the one that I had made earlier. So it was made of ply and MDF. I had put this channel in there. It's in quite a mess. This is a router that I've been using, a Porter cable. It's not 3/4, I think it's about 2.5 horsepower motor in there. And I had a lift installed inside here, and also had a fence at the back. So all this, all these, these channels were there, and so the lift would move forward, backwards, and we had a lift which you could up and down the bit and do the job. But the problem was not so much a problem. I'm not very happy with the table. It wasn't made when I was making it, wasn't done in a proper way, and I'm now trying to build a new one. So I'm going to take you through the journey of me making a new router table, and I hope that you're going to learn something from it. It's an exciting process and a project for me, and I'm really looking forward to it. The difference between the one that I had over there and the one that I'm making now is going to be the fresh one. The new one is going to be based on metal. It's going to be based on metal base, and the top is going to be a metal top. So it's going to be a cast iron top, and the cast iron I have given it for making. So these guys here around me, they have a cast iron, what do you call it, a mill or a forge, I suppose it is, and they are going to forge me a top which I'm going to get CNC milled afterwards. Now this is the fence that I'm working with. I had gotten it from Alibaba, or was it AliExpress, one of them. And this is the lift. They're pretty decent lifts. They get the job done. I haven't used it extremely, I haven't actually tested its accuracy to the degree that one could. But as you can see, this is where it locks. This is the hinge which locks into the router table, the motor. It holds it, so you can loosen it, and if you loosen it, you can see there is a wiggle and a play, and when you tighten this screw, it pulls it towards itself. There is a screw in there. I wonder if you can see it. When I twist it, it's in there, and it starts to, you see, and the more you loosen it, that's the screw, and when you tighten it, it starts to pull this towards itself and eventually ends up tightening, and it holds the motor in place. This is a 4.2 inches opening, and they have adapters for it, which you can reduces. So you can put this in the middle, and right now it's tight. Well, let me show it to you. So if you open it, you could put this in the middle like so, and then tighten the whole contraption. I can't do it while I'm holding the camera. Let me put it on the stand. I wonder if you can see it like this. And so here's the reducer, and I can actually screw it tight like so, and here you see This is the key that they gave with it, the wrench, and we can tighten it. And now this thing is fairly tight, and this reducer has reduced it from so now this is going to work with it's brought it down to 35 millimeters. No, that's okay. 3.5 inches. It's in inches. So it's brought it down from 4.2 inches to, I don't know if you can see it, it's brought it down to 3.5 inches, 3.499. So that's a reducer. If I was to use the original opening, it's somewhere around 4.1, a little over 4.1. So it's a very good tool to have. It's a very good tool to have. With the fence, if you use it, it's really amazing. The problem that I had with my table, as I mentioned earlier, was that it was I just didn't like the channel in there. It wasn't, you know, I had to screw in those channels like this, like these ones that I bought. This is I believe this is a 19 mm channel. There are ones with the 6.3 mm channels as well. What I'm looking at is now the plate that these guys are going to make me for the top. It's going to be 3 by 2 feet. So 3 feet by 2 feet, which is 36 by 24 inches. That's a pretty big one. Normally it's smaller than that, and I know that, but I've gone for a little overkill. And the idea was that maybe if tomorrow I want to reduce it, so I'll tell the guy at the CNC to cut it smaller. But we're going to make two channels running parallel to each other, one 19 mm, 19 or 20 mm, and the other one is going to be 6.35 mm. They're going to be together, and whichever linear you have with you, the rail, the runner, you can use with it. So that's the idea. And the base is also going to be metal. So I'm using a 2 inch by 2 inch, 2 by 2 square pipes. And that's going to be the base, the table base. The top is going to be that cast iron top that I just mentioned. It's, by the way, I've told them to forge it in 25 mm, so which is about 1 inch. 1 inch thick. That's quite heavy, because the weight is going to be alone, when they forge it, it's going to be about an 80 kg heavy cast iron top. I think that's a little, that's inappropriate to sum it up. I think it's inappropriate to have that heavy a top. So what I'm also looking at is actually milling, you know, center pieces out of it where there is no channels. The reason why I kept it that thick is because I wanted the channels to be at least 18-20 mm deep. I think that's the normal standard. If we could look at this one, I wonder how thick it is. I can do it, but I think it's somewhere around 3/4 of an inch. So I wanted that kind of a little more thicker than this, so that when I do it, when we make the channel, there is enough space left at the base for it to have a base. So that's why I got a 25 mm or a whole 1 inch thick plate. It's very heavy. It's so heavy that when I was trying to put it in the boot of my car, I could not lift it alone. I had another person come and help me, and the two of us couldn't do it as well. So we had to get a third person to lift it with us, and it was horrendously heavy. So I'm thinking, and I'll send it to the CNC guys, and they are going to mill out portions from it so that we can reduce the weight, and the channels will stay thick, so that new channels are done. There is a good thick base in it, at least 4 5 millimeters, or